Today we're going to talk about a transportation project in particular that was used in AnyLogic, analyzed in AnyLogic, and it was actually a very difficult problem to solve, and it talked through the steps that we used to be able to do that. A little background, I'm with TranSystems, and we're an engineering firm that's dedicated to projects in the transportation and supply chain space. I'm part of the practice area in operations, modeling, and analysis. We have a dedicated group that does that across all of our different transportation projects, whether it be railroads, airports, roadways, seaports, transit, and even we do things like supply chain network, freight analysis and planning for different customers. In the supply chain space, we do work in industrial facilities, distribution centers, done a lot of work in quick service restaurants over the years, healthcare operations. So you can see we bring a very broad base of experience to our projects, and it's kind of interesting to be able to take things that into the transportation world that maybe have something to do with a completely different domain, but it's just having that experience and showing that, well, that's kind of similar to that, and we can kind of use the analogies for our different projects. Some of the things, we do a lot of modeling, but we've learned over the years that there's a lot of supporting data and other tools that really help the process. So we've gotten involved a lot with big data analytics using GPS. We did a project for the Port of Vancouver in the last few years that uses GPS data to drive our models. It's very useful because being in modeling for quite some time, data has always been a difficult thing to be able to get. It can be time-consuming, expensive, and difficult to obtain. And using some of the new data sources, such as GPS for transportation projects, gives you a renewable data source that you can kind of get continual data and understand trends and be able to use up-to-date data for your models. We also are using geographical information systems as part of our user interface and data for defining networks and so forth, so that's a very useful tool as well. So the bottom line is that we have a lot of different tools and techniques we've developed over the years, and we can tailor the solution that best needs the project and do it the most efficiently. Here's our NASCAR slide of some of the different customers that we've worked with over the years. You can see a grouping of railroads and transportation clients, Volpe, and we've worked with a lot of the major production, quick service restaurants. This is just a partial, healthcare, goes all over the map. And we've also, through our projects, done a number of different domain-specific solutions that we've packaged using simulation, and we've created desktop and server-based decision support solutions for the shipping industry and the healthcare industry and the postal service and the restaurant industry, just to name a few. We've obviously done a lot, and what we can say is, what have we accomplished through that? Well, we've accomplished building a lot of really amazing models and a lot of amazing tools, but we've also realized that creating useful models is something that is not the easiest thing to do. It's also something that is what really is an art and a science. You really have to look at not just the capabilities of your tools, but really what is the best way to apply it. So the important considerations for our modeling projects is really to balance the level of detail with your analysis needs. Include the right things that you need to support your project. And the bottom line is, just because you can model it doesn't mean you should. With the wealth of tools and capabilities that we have, you have to really kind of decipher what is really necessary for the project at hand. And that's the bottom line is, it takes a little bit more work to do that. It's a lot easier to dive in on the keyboard and start doing things, but it really does take more time to really say, how do I best address this problem and do it efficiently, because a lot of times you have project deadlines and you need the answers and you don't have a lot of time to be able to find the best modeling approach sometimes. So our development philosophy is really starts with understanding the domain and the problem to be solved. We always find, if we have the opportunity, if the project's at that stage where we can do a field visit, we always learn something from that. We also like to understand the business objectives and have meetings and interviews with different project sponsors and stakeholders, because it's important to understand what their business objectives are for a project and infuse that into your modeling. And then we also have to be cognizant of how your solution is aligned with the stage of the project. Earlier on, you may not have a whole lot of data, so you have to kind of frame your problem a little differently than if you have a lot of data. You also, what level of design has already been accomplished for that project. So all these different factors have to come in on your approach. And one thing that we've also learned is it's very important, especially with customers that maybe haven't had a lot of experience with modeling, is to keep them involved with the process and help them understand your underlying assumptions, because customers will have more confidence in your results if they feel informed and they understand what's going on. Probably the biggest driver of what the approach should be is based on the project stage. Especially for transportation projects, is that very earlier on, you may not have a whole lot of data and you want to make a lot of decisions, so it's very important to have a lot of flexibility in your modeling to do the planning variables and do the what if. Later on, when you've spent some time engineering something, you're pretty far along in the process, but you really want to kind of tweak it and do fine-tuning to really understand if my system is over or under design, and if it maybe has the robustness to deal with the different variations in your environment. And then finally, in operations, you probably want to even get even more detail, where you really want to get very specific on scheduling and things like that. So this is really what you have to consider when you're developing your model, is where you are and where you want to go with your model. Probably the best way to understand some of this is with this project we did for Port of Long Beach. It's called the Pier B Rail Support Yard. And I chose this project because looking at the theme of this conference is, having success with AnyLogic. And really, this is the first project that comes to mind when thinking about that theme, among all the other projects we've been working on. And I'll kind of explain why. We've done a lot of different rail projects and transportation projects, as we were talking about, for the Class 1 railroads, for regional operators, for, ports, the list goes on, for terminals and for rail corridors. And we've also developed a number of tools to be able to support these projects. We use AnyLogic, sometimes even by itself, but we've also packaged AnyLogic into our own tools called Transportation Modeling Studio Terminal and Corridor that help us, reuse the AnyLogic modules that we've developed into these kind of problems, especially in the terminals where there's always, some reusability of some of the code, and this allows us to do that. And we also use some other tools outside of AnyLogic, such as the rail traffic controller, that are used for the rail industry. And we actually have built translation tools between the AnyLogic and the rail traffic controller to help, use that tool more effectively as well. Now getting to the specifics of the Port of Long Beach, I don't know how many of you are familiar with the Los Angeles area, but it's a real busy area, and our project site here's kind of a sketch of how it lays out. The orange lines are actually the tracks, the receiving and departure tracks, where they may lay out to fit a 12,000-foot train. So this really gives you a perspective how a 12,000-foot train fits into the busy section of Los Angeles. It's quite daunting when you look at it from this, and how environmentally sensitive it is to create a project that fits within this footprint. Because even within this footprint, there are streets and there are neighborhoods that are going to be impacted. So it was important to get the right size of this facility. Just a little bit of project background about the Port of Long Beach in LA. They are the biggest North American ports. It's also coincident with Southern California, which is also a very big population base. So about 50% of all the cargo that enters Port of Long Beach in LA stays within the region, but the other 50% has to go outside. And about 30 to 35% of that will actually go on what they call direct rail, where the intermodal containers will be taken off of the vessels and more or less put onto trains right at the marine terminals. So, and that has a lot of advantages, for the railroads. It gives them a more, less handling. It also provides for the region better air quality because you don't have as many trucks. It reduces the amount of congestion and safety issues. And it just gets you to the, long haul U.S. destinations quicker. Chicago and Texas, you can get there a lot faster. And to be able to do this project, we were talking about $1 billion were some of the numbers that were thrown around. So, it's anywhere between $500 million and $1 billion for this project. So it was really important to figure out really what you need before you spend that kind of money. The thing that's interesting about this being a success story is that the Port of Long Beach has been modeled before. It was underwent a multi-year modeling effort before we got involved. And while it did identify that there was a need for this project, it really wasn't able to tell you what you needed for this project. And so that's where the AnyLogic came in that the previous modeling used a tool and approach that's more aligned towards mainline analysis, getting into the meeting and passing of trains on, large, long rail corridors. But the Port of Long Beach is not, even though it has mainline tracks, it is not a mainline corridor. It is really an aggregation of terminals that have to be ready to receive a train when it arrives from Chicago, for example. It has to sometimes accept mixed trains that have to be broken up and put into multiple terminals, and all kinds of activities that are not what you typically see on a main line. So the problem we had is to reflect the real challenges in the port rail system and to understand how a new rail facility will improve the operations and provide the needed capacity. That was really our bottom line question, and that was really going to be the way that we were going to get the stakeholders to approve this project. And the primary stakeholders being the two Class 1 railroads, BNSF and UP, as well as some of the steamship lines. So it was really important to prove to them that this new solution was going to be able to fit their needs. The problem we had to solve is that we worked in conjunction with the design and engineering team, and they had developed literally dozens of different layouts. I mean, I remember going to a meeting and the room was literally, had drawings all around the room pinned up. And it was just daunting how many different ideas that were floating around. And it really became apparent that this project, to get it moving, was to narrow or screen some of these alternatives. There were just too many to live with. So what was really important for us is to have a quantitative method to filter these alternatives, to get some of the ones that aren't going to provide support the objectives of this project off the wall and focus on the ones that are important. So, living with the goal that the forecasters at the Port of Long Beach from the San Pedro Bay ports was 30 to 35% of the cargo that comes into the port is going to be a candidate for direct rail. And there was a lot of science and economics and so forth that went into that number, but that was the number that we had to live with. So to support this goal of understanding, how big a facility, what type of facility we should build, we used an AnyLogic new modeling approach, and that included all the rail activities in the port area, not just the main line movements, but the movements that go on inside the terminals, the on-dock terminals, the rail support activities that have to occur, the fact that sometimes trains will arrive to the port and not be able to directly come into the terminal. All those things were modeled into this system. And that's why AnyLogic was selected, because it really did allow you to include the rail aspect of it, but it also allowed you to include the process aspect of it all together into one tool, and that was a strength of our approach. And it gave us a way to visualize the train movements, which became especially important later on in the project. So as part of any modeling projects, especially something like this, is that we went and visited all the marine terminals and the railroads and all the stakeholders at the port, which was quite a few people. We went to each one of them, had interviews, got a really good feeling of what their challenges are. And that was a really good thing. We learned a lot, but it was kind of a challenging thing because we saw a lot too. And we saw that there's a lot of tactics that go on in these facilities and a lot of games or tactics that are played on a day-to-day basis to get trains through, the port. And that's what was important to look at, is like, what is a game or a tactic versus what is a process that you really want to be doing. So we focused on a plan for success approach in that we modeled what you want to be able to do from a railroad process perspective rather than some of the tactics that are used, because those are not necessarily productive things. Some of the things we learned about were, what type of, each terminal had its own characteristics. Some of them, they shared some of the same challenges, but some of them had very unique challenges because of the layout and the way that particular terminal was positioned in the port. One of the terminals is way at the bottom of the port, so that they had to live with all the problems that go upstream. So we learned about all the challenges and how to best address them with this new system. Oops. So with the size of this project being as large as it was, it really made sense to break it down. The first step we did was, to get rid of all those different alternatives that were on the wall that we needed to narrow down, is that we did a first step of modeling that was actually done very quickly, maybe in a couple weeks, to really kind of understand how big does this facility need to be. And what we quickly learned was that every square inch of the property that we had available and that you saw previously was going to be needed for rail support and rail switching. There was no room left for some of the other ideas that were a container lifting facility. Those just had to come off the table if you wanted to meet the 30 to 35% goal. Then we did a step two. Once we learned that we're going to focus on a dedicated rail facility, is that we looked at conceptual layouts with more constraints so that we could understand how we would be able to get those volumes through our particular layout. And then finally, as a step three, we did a visualization to the port stakeholders so that the general port community could understand what this rail yard was all about, because there was a lot of misunderstandings of why such a complicated rail system was needed. The thing is we also learned that there was, because of all the stakeholders, there were a lot of concerns. So we had to have the modeling be able to explore the trade-offs that the different stakeholders were concerned about. One thing that we had a variable to look at was sharing of the tracks. BN and UP wanted to have their own dedicated tracks to start the project over, but we realized that if they have their dedicated tracks, that there would not be enough capacity to achieve the 30 to 5% goal. So we quickly learned that the sharing of the tracks would really kind of help bring our capacity to the level that we needed, and we got agreement from the railroads after we showed them through the modeling that this would be the case. Then there was also a lot of contention about the Longshore Union in terms of their work practices. We talked to the unions, we understand what types of practices they do have, safety rules that have to occur. We put those into the model to make sure that we had a system that dealt with their safety issues and their practices adequately, and also showed that in certain volume situations that some of their practices would have to change. So that was another thing. We looked at being mostly an importing nation, we had some issues with the backhaul of containers, meaning that the empty containers that are consumed in Chicago and elsewhere, they eventually make their way back to the port, but they don't perfectly make their way back from the same port that they came in. So we had to look at, what's the proportion of containers versus rail equipment, and how much extra rail equipment would we have to bring in to deal with that shortfall. So all these things were brought into the modeling, and we also had to look at the regional traffic. We're right next door to Port of Los Angeles. We had to worry about how that, those variables were going to come into play and make sure that our project could coexist with the other operations that are going on in the port. One big challenge we had is to figure out, how do we measure success? And it sounds kind of simple, but on the same token, it was kind of a challenging question to ask. In the rail community, there's very typical measures of delay and speed and things like that. And our modeling, of course, has all those outputs. But how do you really say that how fast a train is meet the 30 to 35% goal? So the way we came down to it is that for every single terminal, we had 6 in our port that were our primary users, is that we had the vessel calls that came into the port. And we had outputs designed to understand if vessel calls, if the containers that are targeted to go out by train could be adequately taken away before the next vessel would come. So this is an example of the outputs that we used, and you can see like the big arrival of a vessel being the peak, and then the stair stepping down is how the different trains are taking away those containers after the vessels arrived. And what's interesting to see, and this is a perfectly balanced one, when we were doing the runs, we found quite a few that you had unstable results where containers would continually pile up and never leave, which was not a good situation. This one is a perfect one in that you see the stair stepping of the vessel come and pretty much vacate the terminal, all the containers vacate the terminal before the next vessel comes in. And we had some scenarios where maybe there'd be a lot of space between those big arrivals, and that would show that maybe we were over capacity for that terminal. So we could look at it from both directions. And here's the one in the earlier stage. This is the model, the AnyLogic animation. We do have an animation on that. We'll show you in a second. But it also shows that we looked at this as a system level, and then we abstracted the tracks in the port. And you can see in the yellow chart is how we looked at it more from how many movements could you do at a time. So we could turn that on and off very easily. Okay, let's say right now we have the current situation where we can only move 1 train at a time at that particular location. But let's say if we could have 2 and see if that made a difference in terms of how well the system performed. Here's the animation that we had, and this kind of displays some of the outputs and how the different activities are going on. The little graph that you see in there is the number of tracks that are being used for receiving and departure and how many are active at any given time. And all the flashing text is the individual trains that are coming in and out and the destinations they're serving and all the details that are going on within the port. This was really a successful project. At the end of the day, by doing all those variables and being able to have the stakeholders involved with the modeling process and, understanding that, when we tested their scenarios, that it behaved the way that everyone, approved of, was really instrumental to this process. And we were able to get phasing plans to show how big does this particular project need to be at certain years, and it was approved by the Port of Long Beach Board of Executives, and we also got letters from all the key stakeholders saying that they approved the project. So it's now rubber stamped and going through the environmental process, which is no easy process from what I understand, but we have actually used the model in a kind of follow-on way to support the air quality numbers that are needed to justify the project. So it was a use that wasn't originally intended, but since we're modeling every train and every activity that's going on in there, we can measure the pollutants that the different engines and so forth are producing. And then finally, the AnyLogic, we created a visualization of this system. And we used in AnyLogic, the train library, the rail library, outputs to create an animation, and we embedded it into this video presentation that they use to kind of help explain to people what this project is all about and why you need to spend upwards of $500 or $500 million on some railroad tracks. And it really is once you watch it, it takes a number of minutes to watch, but you can see how busy this place really is. I mean, we have this thing running for probably the course of one day, and you can see, trains coming in, trains being broken up. You can see them being stored, all the different pieces that have to happen in this yard. And this runs on for a while, but I thought, maybe we could watch it if there's any questions. that anybody would like to ask about the project and some of the challenges and so forth. I'd be happy to answer them at this time. Yeah, so you can see some of the different direct arrivals. Sometimes the trains get there. The preference is to directly arrive into the port if you're a long-haul train. But in some cases, if the terminal is not available, they'll have to stop in this yard. Or if it's a mixed train where they have to break it up to take the containers to multiple terminals, they'll have to stop here as well. If you watch it long enough, you also see sometimes there'll be a direct departure, and that's a preferred operation where the train is completely assembled in the marine terminal, and then once it's air tested, ready to go, it just leaves the port. But that doesn't always happen either. Sometimes they have to mix trains going out. So you can see all those different activities and the different yard engines that have to go through and crate these trains, assemble them, and at the end of this, there's actually a scorecard of how many containers and trains were taken into and out of the port in one day.
Quick question. How much do you have to take into account for disruptions in the system? I mean, I know the ports have a lot of issues with either everything from work stoppages to weather or whatever else.
Well, there obviously is that potential to have a lot of that. What we really took the focus on is looking at what is the maximum volume that this facility could do if, if more or less, things are going well. But we did look at factors of how well it could coexist in this area, because Port of Los Angeles is right next door, and it's even bigger than Port of Long Beach. So we had the interfering traffic with that. There's also two major intermodal facilities that both BN and UP, well, actually BN it's not currently built yet, but it's going to be built. So we actually looked at the possible disruptions that those facilities might have, and maybe we also looked at maybe system delays in the Southern California region, that maybe not all trains, when they're ready to leave, could leave on time. So we looked at those kind of things that do happen and the sensitivity to it. Thanks.